Cubical expansion. See, when material is three-dimensionally distributed, suppose this is, if you give heat, lengthwise increase, breadthwise increase, widthwise, all the sides will increase. So if every side increases, then there comes increase in volume. What is that? That experimentally, it has been observed. Increase in volume as we give heat. If I rise it through some temperature, increase in volume. Increase in volume, you can write final volume minus initial. Increase in volume. That is also, let me say, delta V. That increase in volume depends on initial volume. Suppose initial volume is more, then matter is more, number of atoms are more. Then I have already told you, as we give heat, average separation between, because of vibration, average separation between atom increases. Okay? So more we give heat, more the average separation. So more the initial volume, more the number of atoms, and they contribute a more number of atoms, then the average gap between two consecutive atoms will increase. What is just simple thing is, increase in volume, I mean this is directly proportional to original volume. More the original volume, for example, initial volume you have got 2 meter cube. If you rise it through 1 degree Celsius, suppose the increase in volume, you can say 1.1 into 10 to the power minus 5 meter cube. This is the increase in volume. Okay. Now, suppose this is the initial volume. If initial volume, if you take more, if initial volume, if you take 4 meter cube, again you are rising it 1 degree only. Then this time experimentally observed, the increase in volume becomes more. Earlier 0.1, now this time maybe 1, 10 to the power minus 5. Just rough. Increase in volume, even for 1 degree rise, 1 degree rise, increase in volume depends on initial volume. Right? That depends on initial number of atoms. Every consecutive atoms, they contribute for overall expansion. They separate themselves. Every consecutive atom, they get separated because of vibration. Okay, in the earlier class I told you how the average separation increases. So the increase in volume depends on initial volume. Even this increase in volume depends on rise in temperature. More the increase, more the vibration. More they get apart from each other, more they separate from each other. More you give heat, more they start to separate from each other. So definitely increase in volume depends on increase in temperature. So by combining this, you can increase in volume is directly proportional to original volume and increase in temperature. So here we cannot, this proportional design, if at all you want to remove, you have to bring one more dependence. You have to compensate proportional design. What you can, here delta V equals to some constant, that is gamma Vi. What is this gamma? Gamma is one more. Delta V depends on one more thing, that is nature of material. Increase in volume, even it depends on nature of material. Different material will expand differently. So what is gamma? Here right side parts will decide how much increase in volume. So nature of material is also, some material will expand more, some material will expand less. Initial volume is important. You are going with what initial volume? And that is importantly temperature rise also. More the rise, more the vibration, more the kinetic energy, they start to more on and average, they start to go more away from each other. This is there. So what is gamma here? Coefficient of volume expansion. And delta is increase in the volume. Right? So this increase in volume expression can also be written as what? You take that sides, initial volume, it will become plus. What is here? This is, sorry, this is okay, this is there. What is here? So it will be, what is right side here? This gamma, initial volume, delta T. So if you take here, final volume can be written initial volume 1 plus gamma is there. Matter, suppose this is the here. This is one side, it is other sides. Thickness is neglected compared to this length and this length, thickness is neglected. If you give heat to it, what will happen? This length increase here and even this length also increase big. So two sides will increase, then ultimately area will increase. What is here? If suppose this is a plate, this length is L1 and this length is L2. If you give heat, what will happen? This L1 increases up to here and L2 increases like that. That's three-dimensional manner. Okay, here L1 also increases, L2 this that side also increases. Altogether, area will increase. So this side, every side, like this will increase to here. Even that is altogether we cannot on a picture we cannot tell. Like this will increase, every side will increase. So ultimately, the will final area minus initial area. This is increase in area. It always depends on nature of material beta, and it always depends on initial area and increase in same story will continue. Increase in area whenever material is two-dimensional distributed like that area type, aerial plate type two-dimensionally, then at that time everywhere it will increase its length. Like every side will increase. Then finally the area will increase. So this increase in area will be equals to beta times initial area and increase in temperature. So what is area? Let's just simple thing. Whenever if you look at the area wise, then after giving it, this area expanded to bigger area because of heat. So sides will increase. This side, every side will increase. Then finally its area becomes bigger. That experimentally it has been observed. Increase in area always depends on initial area, and even it depends on increase in temperature. And one more term comes. So nature of material. So some material will expand more area expansion is more for some material. For some material, area expansion is less. So this is the aerial expansion. So this take it simple. The area will increase. Here sphere is a three-dimensional matter. As we give heat, all the sides, every part will increase. Everywhere expansion like. So altogether volume will increase. Volume will increase, but it depends. Suppose you want to consider surface area of this sphere. Surface area of this sphere. At that time, increase in volume will help you for finding surface area. Here, sphere is a three-dimensional matter. If you give heat, the volume will increase. As volume increases, surface area will increase. At that time, if you find increase in volume, then you can even find increase in surface area also.
RP.